Thanks.
We can see your slide and we can
great.
hear you. So should all work okay.
Great. Okay. So I'm from the University of Wollongong, and I have just taken over on the 1st of July as coordinator of our brand new Data and Decision Science initiative. So it's a really great time for me to be reaching out and meeting people. So my other roles are directing the National Institute for Applied Statistics Research and the Statistical Consulting Centre. So just really quickly before I get into my research, our Data and Decision Science initiative is looking at 4 particular aspects. So we have a virtual research network, which we've just started, and our focus at the moment is looking at health and wellbeing and social analytics, because these are our research strengths in data science at UOW. We also have a really big focus on education. So we're looking at training in data science and reproducibility of research, not for people who are already working in data science, but we're aiming at improving data literacy of researchers in other areas. And we're particularly focusing on early career researchers, and we're working with our graduate research school as well. We're also looking at upskilling our undergraduates and looking at changing our service subjects to focus more on data science and reproducibility of research as well. And also, as our network progresses, we're looking for external and industry engagement. So my day job is really working in the Statistical Consulting Centre, and my real focus there is looking at data literacy of our research staff and postgraduate research students, and doing individual consulting on research design and analysis. And we also run a number of short courses, again, with an increasing focus on data science. But my research interest is really in looking at dropout from weight loss and lifestyle trials using machine learning. So as I said in the introduction, I have dual qualifications in both nutrition and statistics. So prior to being a statistician, I worked as a dietitian for many years and did my PhD during that time. So we're really interested in lifestyle nutrition interventions at the University of Wollongong, and a lot of our trials have a very high dropout rate. So for example, our last trial had a 53% dropout rate. And this is not only an issue in clinical trials, but for anybody who's started a diet, you'll know that actually sticking with it is the real problem. So while there are ways that we can deal with these dropout rates using multiple imputation, for example, as a clinician, the real thing that we want to do is to stop them dropping out in the first place. So we want to have a look at why people are dropping out of the weight loss trials. So some of the factors that we considered initially were looking at why people developed obesity in the first place. A lot of these are factors, though, that we can't actually change. So we could model for them, but if you want to sit down with someone in a clinic and give them some quick advice, or try and work out why people might be dropping out of weight loss studies, or dropping out of weight loss interventions, we want to be able to look at things we can change. So a lot of these we can't, I'm just working on a different computer today, so these are going a bit askew. So the obesogenic environment is one that you may have heard of, and this is referring to a lack of green spaces, and the others, lack of sleep, inactivity, prenatal genes, individual characteristics, so things like occupation, age, and gender have all been implicated in causing obesity. And of course, overeating. And the food industry have been blamed in this context. Many of you will have seen pictures like this where portion sizes have really increased from, say, 20 years ago. So we want to look in our models for simple things, though, that we can look at. So what I've done is use a lot of the weight loss data that we've collected over the years from our various weight loss trials, where we've used a number of different approaches, including manipulating protein sources, increasing fruit and vegetable intake, manipulating dietary oils, particularly omega-3 fatty acids, and also increasing nut intake. So what we've seen in these trials, regardless of the type of diet that people are on, they follow different weight loss trajectories. And I've classified these trajectories into different types. So we have a group that are rapid weight losers, and people who follow this sort of trajectory only have a low dropout rate. We have maintainers who lose a lot in the first 3 months, and then they tend to maintain this weight loss. And then we have a group that I've called the regainers, who have an initial weight loss, but then over time, over the 12 months of a study, their weight starts to regain again. And people who follow these sort of trajectories are the most likely to drop out. So I've been using neural nets to have a look at these predictors and try and work out, look at some of the predictors that we can easily measure and look at whether these predict dropout. I've also been using CART and random forests and other types of ensemble methods and looking at reasons for dropout. And one of the simplest ones that we've come up with is that within the first month of any weight loss intervention, if you've lost less than or equal to 2% of your body weight, you're likely to drop out. If you've lost more than 2% of your body weight, you're not likely to drop out of the study. And if you put this into a logistic regression model, and one of the reasons for using this is because I need to be able to communicate this to clinicians and they can understand that type of model, they're used to seeing it. So if they have a very small weight loss, they're 5 times more likely to drop out of the study. So I think what this comes back to is that in terms of weight loss studies, we really need to rethink the design. So if early weight loss is a real predictor of whether or not people are going to drop out, is it that we need to measure people for the first month and see how they're going and then randomize at that stage and look at different types of interventions that we can follow at that time? So SMART trials are one that are used, so sequential multiple assignment randomized trials, where you do this, follow them for a month, and then randomize them at that time point, depending on how they're doing, to look at other types of treatment intervention.